Hi, this is hopefully a series of short videos that cover the basic mathematics that you may require for the initial mathematics quiz in introductory microeconomics or macroeconomics. The topics that I want to cover in this video are how to deal with one equation in one unknown, how to find interest rate or tax rate, or how to use interest rate or tax rate in the calculation of values over time, finding the percentage changes using the basic formula and the midpoint formula. We will talk about how to make sense of tables and how to transform or convert the information from a table to a graph. And the last part that sometimes surprises some of the best and brightest mathematically speaking is the distinction between slope and being steep. We will get to that part when we get to. Let's start with the one equation in one unknown. Let's use very simple examples. Let's say the unknown that I'm talking about is x. I'm trying to find the value of x. For example, if 2x is x plus 5, the whole point is to isolate x, the unknown, on the one side and put everything else on the other side. Once you manage to do that, your problem is effectively solved. My goal is to isolate x on the left-hand side. Then I may come up with the idea that if I subtract x from the two sides, my problem is solved. Remember, every time you have an equality, you're allowed to subtract the same value from both sides. You're allowed to add the same value to the two sides. You're allowed to divide the two sides by any number except by 0. And you're allowed to multiply the two sides to any number as you desire. So to solve this one, all I need to do to eliminate the presence of x on the right side is to subtract x. So I subtract x from, let's put it down here, from the right side, but I need to remember I have to do the same thing to the left side as well. Now, on the left I have 2x minus x. On the right I have x plus 5 minus x. 2x minus x. So for example, if you have 2 apples minus 1 apple, that is 1 apple. If you have $2 minus $1, you're left with $1. So 2 of anything minus 1 of itself is just itself. On the right, x plus 5 minus x, x and minus x cancel one another, and I have only a number on the right, x equals 5, and the problem is solved. So let's make it a tiny bit more complicated. 2x plus 5 times x plus 3 is 29. If you have something like this, the starting point usually is to distribute the value outside the parentheses inside. So if you have this value, I start by just repeating 2x, nothing to change here. But now 5 times this parenthesis, I have to distribute 5 inside. So it's going to be 5 times x plus 5 times 3. So it's going to be plus 5 times x plus 5 times 3, which is 15. And I repeat the right hand side without any changes. I can do 2 simplifications at the same time. 2 apples plus 5 apples is 7 apples. 2x plus 5x is 7x. So I have 7x plus 15 equals 29. I want to eliminate the 15 that I have on the left. So all I need to do that is to subtract 15 from the two sides. So I have 7x plus 15 minus 15 equals 29. I need to remember to do the same thing on the right hand side. So on the left I have 7x, 15 and minus 15 cancel one another. So there's nothing else left on the left hand side. And 29 minus 15 is 14. The last transformation I need is to eliminate 7 from the left hand side. In order to do that, I can easily divide the left hand side by 7, but I need to remember I have to do the same thing on the right hand side as well. So 7x divided by 7 equals 14 divided by 7. 7x over 7, 7 and 7 cancel, so on the left I have just x. 14 over 7 is 2, and I have solved this one equation in one unknown. Let's make it a tiny bit more complicated. 1 plus x over 5 equals 1.8. So let's begin with eliminating 1 on the left by subtracting 1. So I have 1 plus x over 5 minus 1 equals 1.8 minus 1. 1 minus 1 cancels, so on the left I have x over 5. On the right, 1.8 minus 1 is just 0.8. Now I have x over 5 equals 0.8. To get rid of the 5 that is in the denominator, I can multiply the left-hand side to 5. So it's x over 5 multiplied to 5 equals 0.8 times 5. X over 5 times 5, 5 and 5 cancel and you have just x, and 0.8 times 5 is 4. The problem is solved. Now let's make it a tiny bit more complicated. Now we have something that might look a little more complicated. You can't just subtract numbers to make them disappear from the left-hand side. Every time you have something over something equals something else over the other, this can be simplified to this times this, or the numerator, or let's say the top part of here times the bottom here equals the top part on the right times the bottom here, which means x plus 1 times 10 equals 11 times x. Now I distribute the parentheses, so it's going to be 10 times x, or 10x, plus 1 times 10, which is 10, is equal to 11x. It's not really helpful to eliminate 10 here, because then if I try to eliminate it here by subtracting 10, another minus 10 will appear here, so it's not really helpful. Instead, I notice I have 10x and 11x. So I need to collect all the x's on one side and everything else on the other. To do this, I subtract 10x from the left and also from the right. So it's going to be 10x plus 10 minus 10x equals 11x minus 10x. 10x minus 10x, they cancel, so the only thing that I'm left with on the left is 10. On the right I have 11x minus 10x. 11 apples minus 10 apples is just 1 apple. 11x minus 10x is just 1x. And therefore x is equal to 10. If it feels better for you, you can just flip the 2 and say I found x to be equal to 10. These two are of course identical. And this solves the problem. That's the idea of one equation in one unknown. And as you will see, it has a lot of applications even in the things that we will do after this. The next topic is interest rates, taxes, finding percentage changes. Let's say you want to deposit your $100 in a savings account that will pay you 5% in interest every year. And you are trying to figure out how much money you will end up with after 1 year if you deposit your $100 in that savings account, paying 5%, and do not touch it for the entire year until maturity of the investment. Let's put 3 notations here. The initial value, let's call it x1. The ending value, let's call it x2. And the interest rate, let's put letter R for the interest rate. This is solved using a equation. Every time you have x1 or an x2, and x1 and r are known and x2 is unknown, x2 can be found using this equation. x2 is equal to x1 times 1 plus r over 100. All you need to do to find x2 is to use the formula and plug in the values for x1 and r. x2 is equal to x1, which is 100, times 1 plus r over 100, so it's 5 over 100. Therefore, x2 is equal to 100. We have to simplify the parentheses. 1 plus 5 over 100 is 1 plus 0.05. And of course, 1 plus 0.05 is just 1.05. So you have 100 times 1.05. It's 105. So if you put $100 in that savings account, let's put the dollar sign here, it means after 1 year and receiving 5% interest in that year, you end up with $105. You may have x2 might be known, x1 might be known, and r might be the unknown for you. Therefore, let's put a question mark here. You don't know r, you're interested in finding r. You know that if you deposit $100, you will end up with $105 after 1 year, and you're trying to find the interest rate. Let's plug in everything we have in the formula and see how we can go about this one. x2, which is 105, is equal to x1, which is 100, times 1 plus r divided by 100. So I want to isolate r. The unknown here is r. And to do that, let's get rid of the 100 that I have here. I need to eliminate this 100, I need to divide everything on the right hand side by 100 to make it cancel. So I want to do a division by 100 to make them cancel, but I have to also do the same thing on the left hand side. 105 over 100 is 1.05. 100 and 100 cancel, so I'm left with whatever is inside the parentheses. So it's going to be 1 plus r over 100. Let's eliminate the 1 that I have here. Subtract 1 and also subtract it from the other side. 1.05 minus 1 is just 0.05. And on the right I have r over 100. Now the only thing that I'm left with that I have to eliminate is the 100 that I have in the denominator. So I multiply to 100 the right hand side and the left hand side to get rid of the 100. So on the left I have 0.05 times 100. On the right I have just r. And 0.05 times 100 is 5. Therefore, the interest rate is 5%. Maybe what you do not know is x1, and you know the values for x2 and r. So let's say if the interest rate is known to be 5%, if the ending value is 105, and the initial value is what you're trying to find, you still use the same equation. x2 is 105, so 105 is equal to x1 times 1 plus 5 over 100. 1 plus 5 over 100, we already did the math for that part, so we know the answer, 1.05. Now the only part that I need to eliminate from the right hand side to be left with x1 is to divide it by 1.05. And of course I have to do it for the left hand side as well. 105 over 1.05 is 100. You can do it by just mental math or using a calculator. And 1.05 and 1.05, they cancel one another and you're left with x1 on that side. So you solved for x1 equal to 100, and as you see, the same formula can be used to find x2 if you have x1 and r, can be used to find x1 if you have x2 and r, and can be used to find r if you have x1 and x2. Now, r is not always interest rate, it could be tax rate, and your money doesn't always appreciate, your money doesn't always increase over time. It could go down. For example, the rate could be a tax rate, a deduction from your original value. If you have $5,000 and the government says you have to pay taxes, so if the government says your tax rate is 12%, meaning you have to pay to the government 12% of your money, then you may wonder how much I have to pay to the government, how much I owe the government. You still use the same formula. 5,000 is your initial value, or x1. The rate is 12%, and x2, you can think of it as money left for you. So you have the original amount, the rate that is applied to it, and the money that you're left with. Because there's a deduction of 12%, you're losing 12% of your money. This is a negative number. So your x2 is x1 times 1 plus, now I have this deduction. It's minus 12 over 100. So x2 is 5,000 times 1 minus 0.12, which is 0.88. Answer is 4,400. So you're left with $4,400 off of your original $5,000 because you gave the government the rest. Now if you compare the two numbers, 5,000 and 4,400, and realize you paid the government $600. If the question is asking you how much money you're left with, you can find x2 as we did. Alternatively, you may just find the percentage of your money that you are supposed to pay to the government. In this case, you would say, I have $5,000. I'm paying 12% of it to the government, so $5,000 times 12 over 100 is what you have to pay to the government. In this case, this is not x2, this is not the amount that you're left with, this is the amount that you're giving the government. This is indeed $600, which is the same number that we found using the other method. So the bottom line is sometimes you're trying to find interest rates, work with interest rates, and sometimes you're trying to find the amount of taxes that you're supposed to pay or the amount that you're left with. If you look at this long enough, you realize that this is basically using the same formula, but it doesn't have the 1 inside the parentheses. Now let's move on to finding percentage changes. Sometimes questions are framed as follows. Let's say the price of a product is $50 and the price has increased after 1 year to $60. What's the percentage increase in the price of the product? In this case, you can think of it again in the same structure as the original value, the value after the change, and interest rate. But if you think about it, this is not exactly interest rate, this is a percentage change. So the question is, how much is the percentage change if the value goes from $50 to $60? To find the percentage change, you can use a formula that basically this is the previous formula that we used for interest rates, but it is put in a slightly different structure. The percentage increase is the ending value minus the value in the first period divided by the value in the first period times 100. And believe it or not, this is the same formula that we had before. So if you start with x2 is equal to x1 times 1 plus r over 100 and you simplify, you can get to the very same formula that we have here. The percentage change is just the ending value minus the original value over the original value times 100. This is called the basic formula for finding percentage changes. Sometimes it is called basic, sometimes it is called the standard approach. Let's do it. The interest rate is going to be 60 minus 50 over 50 times 100. 60 minus 50 is 10. 10 over 50 times 100 is 20%. So if you go from $50 to $60, the increase in that process is 20%. Now, what if I go from $60 to $50? What's the percentage change here? Is this minus 20% or a different number? And to answer that question, let's put the 20%. So when we went from 50 to 60, the percentage change was 20%. Let's see if we go back from 60 to 50, we get to the same number. If you go from $60 to $50, the percentage change is 50 minus 60 over 60 times 100, which is minus 10 over 60 times 100. And if you do the calculation here, if you put it in a calculator, you'll see that the answer is something like minus 16.67. So I did not get minus 20, instead I got minus 16%. Of course, I'm ignoring the decimals here. The problem we are facing is, if you go from 50 to 60, you get one number. If you go back from 60 to 50, you get a totally different number. It is not just the negative of what you originally had. It's a totally different number. Which brings us to the secondary formula, and that's the midpoint formula. The idea is to tweak the formula so that everything is the same, but instead of having x1 down here, instead of having 50 or 60 down here, we put the average of x1 and x2 down here. The average of x1 and x2 is just x1 plus x2 over 2. I know the formula is a little longer, but the formula brings us consistency. By that I mean, if you do the calculations for this one, if you plug in the values, your percentage change will be, in this case, you go from 60 to 50, it's going to be 50 minus 60 over 50 plus 60 over 2 times 100. And this is minus 10 over 55 times 100, 18.2%. And of course, this is a negative number because there is a decline. Now, if I go back from 50 to 60, now the percentage change is 60 minus 50 over 60 plus 50 over 2 times 100, which is 10 over 55 times 100. And because it's just exactly looking the same, it's just here I have a negative, here I do not have a negative, I know with confidence that the answer is the same number, but a positive number. So the midpoint formula, which is using the average of the two down here, is a little more cumbersome to do because you have an extra step to do, but the benefit, the advantage is it's consistent. It doesn't depend on whether you're going from 50 to 60 or from 60 to 50. You get the same number. The only thing that changes is whether it's a negative or a positive. Now let's talk about tables and graphs. On the left hand side, you see a completely made up table that I just put random numbers in. Suppose in years 2020 through 2024, the number of overdoses in the US per 1,000 people has been 5, 6, 8, 4, 3 in these years. If I have a table like this, it has a meaning in it. It is, of course, not just a bunch of numbers put together, but it's trying to convey a message. The message or the information, the contents of a table like this is there's a pairwise connection between the values, which means in 2020 there was 5 incidences. In 2021 there were 6. In 2022 there were 8. 2023 there were 4. In 2024 there were 3. Now let's say the reason there is a reduction here is because of the introduction of Narcan, the over-the-counter medication that if someone is about to overdose, they take the shot and they stay alive. A table like this, it would mean that there was a increase of overdose cases from 5 in 2020 to 6 in 2021 and to 8 in 2022. But because of the introduction of Narcan, helping people stay alive, the number has reduced in 2023 to 4, in 2024 to 3. That's the way a table would paint a picture of the evolution of something over time, for example, if you're looking at the years and the number of incidences like this. We can come up with tables for a variety of things. For example, you may have the age of a child going from age 1, 2, 3, all the way up to their adolescence, and you may have their height. You may have their weight. The bottom line is, every time you have a table like this, there is a pairwise connection, meaning in this year, that's the value. In the other year, that's the value, and so on and so forth. That's the way you make sense of tables. That's the connection between whatever you have in the two titles. As one changes, so does the other. If you have a table, you can transform the table into a figure, into a graph. Every time you want to do that, you need to make the decision about putting one of the two on the horizontal axis and putting the other one on the vertical axis. I think it makes more sense here to put year on the horizontal axis, and so the incidences would go on the vertical axis. Let's say this is the year 2020, 2021, 2022, 2023, and 2024. Let's put some markers here. Let's say this is 8, 4, 2, 1, 3, 6, 5, 7. You don't always have to start from the origin. For this one, I decided to keep it all the way, go to the origin. For some other ones like years, I don't have to go to year 0. It's just unnecessary. To demonstrate, to copy or to bring the information in the first row of the table to the graph, I need to find the point 2020 of the horizontal axis reaches 5 on the vertical axis. So in 2020, I go up to reach 5. This point that I highlighted here contains the information in the first row, meaning it is connecting 2020, year 2020, to the number of incidences equal to 5 on the vertical axis. So just looking, if you don't have the table, you just have this graph, this single point tells you that in year 2020, the number of incidences has been 5. In year 2021, the number of incidences has been 6, so the number of incidences 6 in year 2021, and this is the point that I end up with. In year 2022, the incidences have been higher, it's 8, and this is the third piece of information, the third data point. In 2023, the number is 4. This is another point. In 2024, the number is 3. Now, you can connect them. In the first 3 years, 2020, 2021, 2022, you have an increase in the number of incidences. And the increase in the incidences is shown by the climbing trend that we have here. The line is going up. The line is, as time goes by, remember, as you go to the right, year is increasing, meaning as you go to the right, time is passing by. And on the vertical axis, of course, you have the incidences. So what this tells us is, as time goes by, the number of incidences is rising from 5 to 6 to 8. The mere fact that the line is sloped upward means the incidences have been rising. Now, after 2022, after the introduction of Narcan, you have the trend going down. So as time goes by, the incidences are falling. That's the way you make sense of the graphs. You can start with the table and come up with the graph, or you may start with the graph and come up with the table. The two are connected to one another, and the two are conveying the same message, but graphs tend to be more insightful in the sense that if you are trying to understand what's going on here, you may have to stare at the numbers for a long time, but if you just look at the trends, you can easily say because this is climbing, the incidences are rising, and because this is falling, the incidences are diminishing after 2022. That's the connection between graphs and tables, and we are done with this concept. Now about the slopes and the steepness. The slope is positive here, and the slope is negative here. Every time the graph is going up, as you go to the right, the slope is positive. Every time by going to the right, the trend is going down, the slope is negative. What I want to clarify here is the distinction between slope and steepness, or being steep. Slopes can be positive, slopes can be negative, they can be large, they can be small. Whatever you do for slopes, if you take the absolute value of the slope, you're talking about the steepness. Meaning if your slope is, let's say, 3 or negative 3, there are different slopes because one of them is a positive slope, the other is a negative slope. But if you think of them as a steepness, by taking the absolute values, they are equally steep. If I have two lines, let's say line 1 and line 2, line 2 has a larger slope than line 1. And both of them are positive because both of the trends are upward, they are increasing over. Let's say if I have year and incidences in countries 1 and 2, I can say the incidences are rising in both countries 1 and 2, but the incidences are rising more rapidly in country 2 because the slope is greater. You may have a third country for whom the slope is negative, which means in the third country the overdose incidences are falling over time. The negative slope means a reduction in incidences in this case. Now, if you talk about the steepness, it's to say, forget about the sign, just focus on how tilted or how flat the trend is, how rapidly it is changing. In that sense, if I have 1 and 2, I can say 2 is more steep than 1, but if I have something like this, 1 going up, 1 going down, then they are equally steep. One is negatively sloped, the other is positively sloped. The two are equally steep. For example, the slope of one could be positive 3, and the slope of the other could be negative 3. And because the absolute value of negative 3 and 3 are the same, the two are equally steep. Having that in mind, you can think of steepness as an imaginary ball. If you have a ball that is put on top of the line, how fast is it going to roll down? So if I have two lines, if I'm saying the two lines are equally steep, it means that if I put a ball up there on each of them, the two balls are rolling down at the same speed. If we put a ball on top of two lines and the balls are rolling down at the same speed, then the two lines are equally steep. But if you have one line like this and the other like this, you can feel that if you put a ball on a surface like this, the ball is going to roll down much faster than the ball that is on the first one. The first one has a positive slope, the second one has a negative slope. So if you're thinking about the slopes, the slope here is larger because a positive number is greater than a negative number. But if you think of which of the two is the steeper of the two, then this one is a steeper because if you put a ball up here, it's going to roll down faster. As you increase the incline, the ball is going to roll down even faster. So the more vertical you make it, the steeper it becomes. Eventually, if you have a vertical line, now here is the controversial part. For a vertical line, the slope does not exist, but it is the steepest, which is a little confusing or counterintuitive initially. The idea is the slope does not exist because if you start with a upward line, let's say, if you start with a line that is operate like this. The slope is positive. And if you increase the slope all the way to make it vertical, converges positive infinity. From the right, the slope is going towards positive infinity as you start with a positive slope and make it vertical. Alternatively, if you start with a negative slope and tilt it all the way to make it vertical, you start with a negative slope, and as you make it more and more vertical, the slope is going towards negative infinity. So from the left, the limit is negative infinity. And because the limit on the right and the left are not the same, the limit does not exist. So the slope here is not positive infinity. This is not the largest slope, which is positive infinity. It is not the smallest slope, which is negative infinity. It's neither of them, because it depends on whether you're going towards a vertical line from the left or from the right. So you cannot judge whether the slope is greater than all or smaller than all other slopes. Greater than all, smaller than all. But if you're thinking about not the slope, but the steepness, and you are taking the absolute value of the slope, then from the right, the absolute value of a number that is larger, getting larger and larger towards positive infinity, and the absolute value of a negative number that is going towards negative infinity is going to be also positive infinity. So the limits on the left and the right are the same. They are positive infinity. In this sense, even though the slope does not exist, we feel comfortable with the idea that positive infinity is larger than all numbers. It is not a number, it is a concept, not a number. But if you are pressed to make a comparison and judgment to say whether a number is greater or the infinity is greater, the infinity is greater than all numbers. In this sense, the steepness of a vertical line is more than the steepness of every other possible line. And for that reason, a vertical line does not have a slope, because the slope does not exist, but it is the steepest. Now, if you want to have a little more of an intuitive conversation, forgetting about the math, going back to the idea of a ball that is rolling down the slope, the fastest a ball would roll down would be in a free fall. And a free fall is when you have a vertical line. Of course, this is not a mathematical proof, it's more of an intuitive explanation. Every time you're in doubt about the distinction between slope and steepness, use the metaphor of the ball. Which line lets the ball roll down fastest? That's the steepest. We are getting a little pedantic about the distinction between slope and steepness because in the discussion of elasticities that we will have in economics, we need to make the distinction. We will come up with vertical lines and we need to make that judgment call about which one of the lines is the steepest, and that's when the conversation of slope and steepness come in handy.